Alright, so now we're going to do example number 2 here. And to do this, I'm going to pull out my graphing calculator. You guys can do the same thing. Hopefully you guys had a chance to at least put those values into your graphing calculator. And I'm just going to adjust these windows here, you guys, so you can see what I'm doing here. So we're going to be examining we have three exponential functions there. So here we have y is equal to 3 to the power of x. That one was our original base function there. The second one that we were given there is y is equal to 2 times 3 to the power of x. And then our third one we were given there was y is equal to 3 to the power of 2x. Alright, so I'm going to move this on over here. So let's take a look at what these graphs will look like, and you guys can write down those table values into your notes if you guys like. And I'm going to zoom in just a little bit here so we can have a better look at this graph here. Alright, so our red one right here, this one here is our base function. So that is y is equal to 3 to the power of x. And then our second function there is where we had that a value of 2. So that's this blue one right along here, okay? And if you guys remember, so that parameter a will have a vertical stretch by factor of 2. So if you guys notice, if you guys remember, that vertical stretch means that y value gets multiplied by 2. So that's when we're comparing this function here to our base function. So here originally we had it at 0 and 1. And then it had a vertical stretch where you multiplied that y value by 2, by that factor of a. And so each value, if you guys notice, you guys could go along each one and compare those values there, and you guys will notice that each y value there is multiplied by that a factor, which is 2. Okay, so moving on, we'll write this into the notes, but just I want to show you a nice graph, so that way you don't have to look at my chicken scratch of graphs. So here we're going to examine. So now let's look at this green graph right here. So this is y is equal to 3 to the power of 2x. And if you guys remember that to the power of 2x, that 2 there is that parameter b. So that means that we're going to have a horizontal stretch about the y-axis by factor of 1 over b. So we're going to divide those x values by b, okay? And if you guys note here, x here is equal to 0. So 0 divided by anything is just 0. So that is why this point here stays the same, okay? And if we were to examine any other point, if you say looked at, if we can find exactly 3 there. So we're at 0.5 and 3, whereas when we're at 3 over here, or I guess when we're at 3, we're actually at 1. So if you divide that by that factor of b, so divide that by 2, that is where that factor there is, okay? So we kind of shrunk that graph, okay? Now let's write this into our notes now, okay? And if you guys want to, I can if you guys wanted to do a table of values, that'd be absolutely fine. So I'm going to quickly switch out my pen colors here. Okay, so first to start off, we have y is equal to 3 to the power of x. Here we have x and y. I'm just going to do the table values for just this one, and then we'll go through a little bit about how to use just one table values to graph the rest. So for y is equal to 3 to the power of x, we're going to use x values of -2, -1, 0, 1, and 2. Putting each of those values in, we have 3 to the power of -2, that's equal to 1 over 9. 3 to the power of -1 is equal to 1 over 3. 3 to the 0 is 1. 3 to the power of 1 is 3. And 3 squared is 9. Okay? Alright, so now let's graph that there. So we have, make sure you label your tick marks. We have 1, 2, 3, and 4. -1, -2, -3, -4. And then going up, we will go up, this one we can go up by 4s. Once we get to our third function, it gets to be pretty crazy. So we'll go by 4, 8, 12, 16, and 20 is all the way up there. Alright. So now let's graph this awesome function. So here we're at, when x is -2, we have 1 over 9. It's going to be like extremely close to that x-axis there. We have -1, it is y is equal to just 1/3. Probably not going to look like it's going to change much. Then when x is equal to 0, we are at 1. Go halfway in there. Then when x is equal to 1, we're at 3. And when x is equal to 2, y is equal to 9. Should be right about there. Okay, so now let's graph this. Oh, if I could graph nicely. Oh, yikes. Shaky hands today. Yeah, so it should be a nice smooth line going all the way up. You guys saw in my nice graphing calculator, it should be a nice smooth line, but I have shaky hands today. I don't know what's going on. Alright, so now we're going to look at the function y is equal to 2 times 3 to the power of x. We're not going to do table values for this one. We're going to use those properties that we learned from that graph there, or from our little chart on the first page there. So here we have, with this value here, that's our parameter a. So what's going to happen to that chord is that x is going to stay the same, but we're going to multiply y by that factor of a, okay? So for example, we have, here we'd have negative 2, and for our y value, we're going to have 2 over 9, okay? So multiply that value by that a factor, okay? And we could do this by just by looking at the graph if you guys take a look here. So this one, it's going to be a little bit harder just because we're using such little numbers there. So it's going to look like it's sitting on top of one another, but essentially, especially when you get to the bigger numbers, you're going to see that these are going to double. So when we have 0 and 1 here, that's going to become 0 and 2, so that y value doubles. Here we're at 3, so it's going to be at 6. Here we're at 9, so it's going to be all the way up to 18 there. Okay, so there is a quick tidbit. If you don't want to use this method, that is absolutely fine. You guys can do table values, you guys can use your graphing calculators. That is all absolutely fine. But this is kind of a nice little neat trick. Oh, that is very off. Sorry, my bad. A nice neat little trick so you don't have to do a bunch of table values, okay? So just remember your a value, that a value is going to change your y value. So you multiply it by, you multiply the a and y, okay? So you find your y on the graph and you multiply it by 2. So if it was at 9 here, then it's going to be at 18. Okay, so I'm just going to switch my pen over to a different color now. And we're going to graph our other function. We're going to use green again. Okay, so for that one there we have y is equal to 3 to the power of 2x. And this one here is that b parameter, so that means that our x value is going to change, and it's going to change by a factor of 1 over b. So you divide that x value by b, and your y value stays the same. So for example, let's look at this first one here. We have x is equal to negative 2, so then you divide it by that b parameter, so be negative 2, divide that by 2, and we're at negative 1 and 1 over 9. Okay, so that one causes and if you guys want to label that, so it's a horizontal stretch. Okay, so this one's a little bit even then harder to see. So what we can do then is, so look at that x value. So when here we're at negative 2, so this one, it's a little bit harder to see because normally we would be moving up and down, but this one will be moving left and right. So here when we have negative 2 and 1 over 9, you're going to divide x value by, so in this one we're just going to cut in half. So negative 2 cut in half, so that's actually moving over here. So at 1 over 9, y value is over at x is equal to negative 1. Then we're going to move on to, say, 0 and 1. You divide 0 by 2, and that value stays the same because any number divided by, or 0 divided by any number is just 0, so that one stays there. Then we can move to look at when x is equal to 2, we're at 2 and 9 there. So divide that x value by 2, and we're going to be left with 1 and 9. Okay? So from there, if you want, you can keep going, but this will be fine as it is. So now let's connect our dots there. So I'm not going to have, I will have a steady hand. I promise, oh noes. Okay. So that's kind of what it would look like. Let's take a quick look at my graphing calculator there. It does not have a shaky hand, so it'll look a whole lot nicer. So this is essentially what's going to happen, and I'm just going to zoom out for a little bit so you can kind of see what's going on. So here is our base function, this red one. Here our blue one has that a value of 2, so your y value is doubled, And then here with our green one, your x values were divided by that b factor, or were divided by 2. So it had that horizontal stretch for this green one, and then a vertical stretch for your blue one, okay? So now let's write this into some sentences. Alright, so starting here, we're going to look at that second value that we looked at. So we had y is equal to 2 to the power of, or 2 times 3 to the power of x. And that one there was a vertical stretch. Vertical stretch by a factor of, we can say a is equal to 2, or if you just said by a factor of 2, that is absolutely fine. Then what happened to the domain? Well, your domain stayed the same, so we can just write even d stays the same. You can look at your range, and if you guys compare that, your range stayed the same. So the range is the same. Looking at your y-intercept, did your y-intercept change at all? And that one, remember, so this one, we had a vertical stretch that's affecting those y values, so yes, our y-intercept did change, and what we have now is that our intercept is now at 0 and 2, so that y value doubled compared to our base function. Then we're going to look at the x-intercept. And that one didn't change. We didn't move the graph, we didn't shift the graph up or down, so that is absolutely fine. So we could even, or I guess I shouldn't have a bracket there. So the x-intercept stayed the same, there is none. Alright, and sorry, I don't know how to get that little guy out of there. And then last, we'll look at the horizontal asymptote, and once again, your y value didn't shift up or down, so your horizontal asymptote, I'll rewrite that as HA again, and that one stayed the same. So that is where y is equal to 0. Okay, we change pens here now. We're going to go on to our third function. So this one here we had y is equal to 3 to the power of 2x. And this one here was a horizontal stretch, and I kind of already talked about that a little bit there. So we had a horizontal stretch by a factor. And we can say by a factor of 1/2. Or where b was equal to 2. Okay. Then, looking at the domain, and if you just look, your values just got stretched, so it actually didn't, I guess we can look at the domain and range right now. So your domain didn't change and your range didn't change, okay? So compared to that base function there, so your domain is the same, and your range is the same. Okay, then looking at our x and y intercepts. If you want me to, I can keep on scrolling. Hope you guys can see that into your own graphs. So there are your x and y intercepts. For this green function here, your y-intercept stayed the same, and there was no x-intercept, so that stays the same as well. So both your x and y. Oh. So x and y intercepts are the same. And then lastly, you can look at your horizontal asymptote, and once again those didn't change, so your horizontal asymptote is the same. Alright, so we're going to move on to the next video. Holy wow.